Hi, Brady. Kara, you Brady?
I'm Brady, quarterback. Varsity starting. I'll never be better.
Just know that you're Miss Brady. Just know you're Miss. Okay. Quotient identities. Okay. The word quotient means dividing. So tangent can be seen as sine divided by cosine. Cotangent can be seen as cosine divided by sine. So our cosecant, I can divide 1 over sine. Cosecant, 1 over cosine. Cotangent, 1 over tangent. Okay. Now tangent is also 1 over cotangent. These three identities right here, the Pythagorean theorem identities, are probably the most important. We use that a lot lately, haven't we? To solve, okay, and substitute. Now, even and odd, let me tell you guys about this. Super important as well. Because in proving an identity, the angle's got to be either both positive or both negative. So let's verify which, out of these 6 trig functions, which are the odd functions? Which one's odd? Cosine is odd? Cosine is not odd. Cosine is actually even. So this is even. Which one's odd? Sine is odd. What else? Tangent is odd. Okay. What else? Cosecant is odd. What else? Cotangent is odd. So how many even ones are there? Just 2. Okay. So to know the even and odd is important because let's just take sine for example. Sine of a negative angle is exactly the same as what? Negative sine of a positive angle. Okay, so that's why we want to know even or odd. Now, secant is an even function. Secant of a negative angle is identical to secant of what? A positive angle. So even functions, we don't have to worry about the negative angle because it's going to be the same as the positive one. These are guidelines. Guidelines just means sort of suggestions, okay? No, it's not set in stone. Number 1, can you help me, Celine, read guideline 1?
It's almost always preferable to start with the side containing a more complicated expression.
Yeah, I know. We normally don't want to do things that are difficult, but when you are doing proofs, you want to start on the side that is scary looking, the side that you don't want to touch. That's where you want to touch, okay? 2, Leo, can you have me read 2, please?
Rewrite sums or differences of quotients as a single quotient.
Okay, very good. What that means is, if you see sum of difference or quotient, so what this really means is 1 over x minus, let's say, 2 over y, okay? Those are sum or difference. This is actually difference of quotients. And what it wants you to do is find a common denominator. Rewrite it as a single quotient, okay? So if you see a subtraction of fractions or addition of fractions, it wants you to write it as a single one. It means find common denominator, okay? Can you read 3, please, Yui?
Sometimes writing one side in terms of sine and cosine functions only will help.
Right. Always break it down to basic things that you're comfortable with, such as sine and cosine. 4. Lauren, can you have 4, please?
Always keep your goal in mind. As you manipulate one side of the expression, you must keep in mind that the form of the expression on the other side.
Perfect. Okay. Always remember what we're trying to get to. Example 1. We're going to start with something super easy, okay? We will start with the process writing proofs with easy steps or easy problem. Okay? Simplify tangent divided by secant of theta, and then I'm giving you a hint here, by rewriting each trigonometric function in terms of sine and cosine functions. So let's start. Tangent, how can I rewrite that as sine and cosine? Kara?
Tangent is sine over cosine.
Yep, tangent is sine divided by cosine. Okay. Now what do you want to do? Sarah?
I said it's divided.
Divided by?
For cosine.
Yep. Okay. What's your next step? Flip it. Okay. I see the motion of, so sine divided by cosine times cosine over 1. So the cosine and cosine will reduce. This just get down to just what? Sine of theta. Uh-huh.
It's not stated here. Are we not going to use the cofunction identities?
Say that one more time.
Are we not going to use the cofunction identities like the sine of pi over 2 times theta?
Sine of pi over 2.
It was like we had to use it on the review homework. It was like the tangent of pi over 2 minus theta equals cotangent of theta.
Wait, tangent of pi over 2 is lower. Minus theta. Uh-huh.
Like all equals cotangent.
In quantity like that?
Yeah.
Equals to? Oh, you can always use that. You can always use that. Yeah, no, good question. You can always manipulate that if you see that it works in your proof. Okay. Yeah, when you're writing proof, you're going to use all of your knowledge, really. Okay. And your book might have a solution or a set of key that goes one way, but that doesn't mean you have to go that way. All right, B, another trick here. Show that sine of theta divided by 1 over 1 plus cosine of theta is exactly the same as 1 minus cosine of theta over sine. Okay, let me kind of give you a hint here. Show that means you're proving. Guys, when you're proving, okay, you have to pick one and only one side. You can't prove or write or work with both sides at the same time. Now, when you pick a side and it's too difficult or you can't figure it out, you can exit out or erase it and start again on the other side. But can you work both sides at the same time? No. Okay. So this one, which side do you want to start with?
Left side.
The left side. Okay. So sine of theta divided by 1 plus cosine of theta. Show that means, or establish an identity mean you're trying to get to the right side. So this is our goal right here. Okay. This is our goal. We want to make that left side to look like the right side. In this one, I'm giving you a hint. It says multiply the numerator and denominator by 1 minus cosine of theta. And here's how I'm giving you this hint. Can you see in your goal there's a 1 minus cosine theta in the numerator? Okay, so to get this, we have to multiply both top and bottom by the same thing. So multiply top and bottom by 1 minus cosine of theta. Then step 2, please number your steps so I can follow it. Some of you guys write horizontally, some of you guys write vertically. It doesn't really matter, just number the step so I can follow. So on the top, I'm not going to distribute yet. I'm going to keep it as is. But on the bottom, what would you get if you distribute? 1 minus what? Cosine square theta, thank you. What do you see? What do you see? Identity, 1 minus cosine square theta is always what? Sine square theta on the bottom. Okay, on the top, I'm going to write it over. And guys, in writing proofs, you cannot skip steps. Even the most basic step, you have to write it out. Every single step is part of an answer. Okay, now what? Can I simplify? If I do, am I to the goal? Am I there?
Yeah.
Yep. So step 4, I can simplify these one of those and put one of those. So here's my answer, 1 minus cosine of theta all over sine of theta. That's where you need to stop because obviously that's the goal. Then do me a favor, just so I know that you're done and you're not stuck, put your initial on it. Okay? Your initial at the end means, you know what, I'm done. You can read my proofs. Without initial means, you know, I'm kind of stuck. This is as far as I got. Initial, own it. You got it. You're done. Non-initial means I try, but I'm kind of stuck. This is where I'm leaving it. Okay? Now, what if some of you pick the other side, like the right side? 1 minus cosine of theta over sine of theta. What would you do to get the goal on the left side? Multiply top and bottom by what? Yeah, 1 plus cosine of theta. And again, some of us will start, and again, it doesn't matter what side you pick. You just have to work it out slowly. Then on the top, I would now have 1 minus cosine square of theta. On the bottom, I now have sine of theta times 1 plus cosine of theta. On the top, I would turn that into a what? Sine square of theta. And do you see the process is very similar? Okay. Yeah. Okay. And if you get stuck, then don't put your initial. But if you are done and you feel confident about it, put your initial. Let me know that you got it all. Okay. So either side, pick a side. Sometimes one side I can't even do it. Okay. So I have to work the other side. You mean?
Would we get marked down for doing the right side because like
of the instructions said?
No, you can pick any side you want.
Okay.
Pick a side. But one of the guidelines said to pick which side?
The left.
Not left. What did it say? The more complicated one, okay? Because it's easier to go from big to small. All right. Now, what if you see stuff like this in one of the sides? Simplifying 1 over 1 minus sine of u plus 1 over plus cosine of u. Remember one of the guidelines said if you have some or different quotient, this is what it is. Try to make it into one single. So what that means is doing what? Yeah. So I'm going to rewrite it really quickly. 1 minus sine of u plus 1 divided by 1 plus sine of u. Okay, what's the common denominator here? What's your common denominator? Yeah, just both of them together, right? So here's a big quantity. 1 minus sine of u, 1 plus sine of u, 1 minus sine of u, 1 plus sine of u. All right, so now that I have a common denominator, what should we multiply to the first fraction over here? What's missing? 1 what? 1 plus sine of u. Okay. What do we multiply to the second fraction? 1 minus sine u. And again, some of you are extremely great with basic math. You cannot skip steps in proofs. I don't care how good you guys are. Okay. Guys, you can't tell me, oh, I meant to write that out. When I'm grading your test, there's no you next to me. I'm just reading what you have in your paper. Okay. I know some of you, when you guys are solving, I don't mind if you skip like 5 basic steps, but when you're writing proof, do not skip steps. Okay. Right, because they have a common set of denominator, can I put them together?
Yes.
By the way, can I even multiply those two guys in the bottom?
Yeah.
Yeah, what's 1 minus what? Sine? Square of u, would that be okay to do? On the top, can I combine anything? Can I divide anything? What's on the top? Subtract? The sine of u cancel?
Yes.
And what do you have left? 1 plus 1 is? 2, okay. Can I go further? Yeah, I can go further, okay. I'm out of space. Let me number these because now I'm going to go horizontal, and that's going to be very confusing to my teacher. All right, 4. What are you going to do? What are you going to do to simplify? I can't hear you. Identity. What identity are you thinking about? What? Yeah, totally. This is cosine square? Is that as far as you can go? Oh, yeah. You got to go. You got to go all the way. Isn't that 2 times 1 cosine square of u? Like that? Yes or no? Oh, can I stop there? No, can't stop there. What are you going to turn that into? Sarah, you said it. Secant square of u. That is how we simplify all the way.
Can you skip step 5?
Can you skip step 5? Yes, but everything else, no. Okay. But more steps are always better. Okay. This is one of those things. More is not less. More is better. All right. Let's do D. Another way to kind of break things down is by factoring. What would you factor? Can you factor the top? Can you factor the bottom? Okay. What are the factors for the top? 1 plus cosine of v times 1 minus cosine, of v all over. Can you factor the bottom? Yeah, what are you going to do?
Take out sine.
Yep. Take out a sine of v. Then I have 1 plus cosine of v. What's your next step? Cancel. You're right. These two guys can definitely be canceled. So step 2, 1 minus cosine of v over sine of v. Is that as far as you can go?
No.
No. What are you going to do? Kara?
Well, you can like separate them and be like 1 over sine of v minus cosine v over sine of v. Then cosine v over sine of v cancels tan. I mean cotangent. Wait, no. Cotangent.
Yeah, okay. Earlier we took this and we put it together as a one fraction. If you have one fraction, can you break apart to make it two fractions? Yes, you got to go back and forth. 1 over, and yes, you are required to write this step on your proof, okay? Because I won't know where you went. So step 4, what's next? What's 1 over sine of v? Cosecant of v? Cosecant of v minus cotangent of v. And that's as far as you're going to go, okay? Because I don't think I can break it down or combine anything else. Okay, more steps are better than less steps. All right, let's try the real stuff. All right. Establish each identity, aka prove this. There's no easy way, like I said, and I can't lecture very much. Doesn't matter what I do, how many proofs I do, it's not going to help you if you don't try on your own. You're all going to pick your own style. Eventually, you can have your own system. Okay. Everyone will have a different way to start and end their proof, or aka identity. Try one side. If it doesn't work, scratch it and try the other. Do not double dip. That's a big no-no. Do not work from both sides at the same time. The solutions from the back of your textbook is only one of the many ways to complete each proof. Okay, let's start with this one. Pick a side, pick any side. Left. Write number 1 and number your steps and end the proof with your initial if you're confident and done. So sine of theta, cotangent of theta plus tangent of theta. What's your goal? Get it to secant. All right, step 2. What do you want to write?
Convert cotangent and sine to sine and cosine.
Yeah, break it down to sine to cosine. Sounds like a great idea. So cotangent is what over what, Ryan?
Cosine over sine.
Cosine over sine. And again, do not skip steps, okay? Tangent, Lauren, is what, dear? Perfect. Okay, step 3. What might you want to try, Ashley?
Maybe the same denominator so you can combine the fractions.
Was that okay to make the same denominator? Yeah, it's okay. You do that. Some of you will also do what? Yeah, there's really no wrong way. You're going to find your own rhythm. Okay, so we're going to follow Ashley for this one. If you don't like that, go do your own thing. Ashley said I'm going to make a common denominator, which is I'm going to multiply this by sine of theta and cosine of theta. This is sine of theta and cosine of theta. So on the top, Ashley, what would you get now on the top on that first fraction?
Maybe cosine squared.
Yeah.
And then on the other one, sine squared.
Beautiful. Okay. Then step 4, because we have gone this way, I'm just going to put it over one fraction. So sine of theta times cosine of theta. And cosine square plus sine square, class, I can change that into a what? A 1. Okay. All right. Amanda, what do you want to do next?
Multiply, so it's like sine theta over sine theta over.
Yeah. Perfect. Can I leave it like that?
Cancel out the sine.
I can cancel the sine. So step 6, what do you have left?
1 over cosine theta.
And step 7, what do you have left?
Secant.
Yes. And guys, secant is what we wanted. You don't have to go back and put secant equals secant. So I can just, yeah, someone have your hands up.
Do you have to write that first step?
First step, where are you?
Just rewrite the one side.
You do. You have to write that first step because I don't know what side you pick. Okay, good question. Question is, do I have to write a side? Yes, you have to write a side that you use because otherwise I don't know what side you started with. Yes. Can you skip number 5? Technically, yes, but nothing else. Always more steps are better. Yes, Kara.
Like last year, Mrs. like Patterson, I guess, she had this like at the end she had this 1 over cosine theta equals like secant theta, and you have to write like that specific way. Instead of like doing this step, you just have like at the end she like finish her free form.
That's about the same. So yeah, I'll take that.
So,
Yeah, I just number my steps so I can just follow it.
so I don't have to follow her.
You don't have to follow her. It's the same though. You know she can listen to this, right?
Okay.
Yes.
Everybody in the world can listen to this, Kara. Okay. Alyssa, pick a side. Pick any side, dear. What side?
The right side.
Sure. Let's try with the right. There's no wrong way. That's why we all have a pencil, right? And a big eraser? Okay. All right. Left. I'm sorry. What did you say, Alyssa? Right side. Okay. Sine of theta divided by 1 plus cosine of theta. And I can't help you, so you're going to have to write, okay? 2. What do you want to do, Cole? There's no wrong way. There's no right way. We're just going to try it out. I'm so glad you said that, by the way, because you cannot square root. You can multiply by 1, you can divide by 1, you can add by 0, you can subtract by zeros. But, and here's why. If I give you 4 over 9, is that equivalent to 2 over 3? Question mark. If I give you 4 over 9, is that equivalent to 2/3? No, because 4 over 9 is less than half, right, y'all? If you're going to take a square root, like you said, it's now over half. It's 0.6 repeating. So are these two equivalent? No. So in writing proofs, can you square root anything? No. So don't square root. But you can multiply things by 1, you can divide things by 1, you can add things by 0, and you can subtract 0. Okay? When I say multiply by 1, that means the top and the bottom must be exactly the same. Okay, so Cole and team. Consult your team, Cole. Or would you like to pick a different side?
Yeah.
Okay, I'll do both ways. I don't know if one's better than another. Okay, Cole, you pick left side? Sure. Then Cole, what's your step 2 if you have chosen left side? Okay, so 1 over what? 1 over sine theta minus cosine theta over sine of theta. Okay, so we scratch out this side. See, and remember, you can't go both at the same time, so pick one. Step 3. Now that Cole has switched side, Kara, what do you want to do next?
Oh, I combine it all over sine, so I got 1 minus cosine theta all over cosine theta.
Good. Check out your goal. Check out where you want to end up. Have we seen something quite similar before? Okay. What do you want to do next, Emma? Consult your team. Talk it out.
Multiply top and bottom by 1 plus.
Okay. Multiply top and bottom 1 plus cosine of theta. 1 plus cosine of theta. Do you guys agree, Emma? Yeah. Look at your goal. Okay. Whatever the goal has, that's what you want to multiply by. Then step 4. What do you guys want to write in step 4? 1. What? Minus cosine square of theta all over. Should I distribute that or leave it? Leave it. Can you see the goal has one of the 1 plus cosines? Okay, so leave it. 1 plus cosine of theta. Now what? Okay, so sine square of theta, convert the numerator over sine of theta times 1 plus cosine of theta. Are we almost home? Pretty close. So can I cancel one of the signs? I'm left with 1 on the top and 1 plus cosine of theta on the bottom. Oops, I meant sine on the top. I'm left with sine on the top. Am I home? Yeah? Cole, are you home? Yeah. See? Okay. So again, you can pick a side and it doesn't work for you. Try another side, but do not double or dip. Do not work both at the same time. Okay, you try C out. Pick a side. Pick any side. If I were you, I would pick what side? Yes. Pick the left side. Oh my gosh. Okay. We have up to F and that's it. So once, if you are stuck, okay, maybe turn to your neighbor. Like, hey, read my proof. What else can I do? Again, if you're stuck, just turn to somebody and be like, this is where I got. This is how far I gotten. I'm kind of stuck. Do you want to work together? Did you break it down to sine and cosine? Yeah. Did it get you anywhere with that? Starting to? Okay. Yeah, if you ever come to me for help on proofs, I just have to try it out like from scratch because I don't have like a picture of where I'm supposed to go. And I just have to work it out and pray that it will go somewhere. Oh, you got it? Okay. Yeah. Talk it out. It doesn't hurt to talk it out. You got it? Yeah? Okay.
I have an iffy move, but.
An iffy move. Make sure you verify with me, okay?
Okay.
Can you have a keyboard for me? Okay, before I go further, anyone pick the right side at all? I want to make sure if you got creative somehow. Okay. Oh, so I think most of us broke this down into sine and cosine. So that's the numerator. I'm going to write the denominator this way. Is that okay to write sideways? Yeah, okay. Then what do you guys do next?
Could you cancel both sine and cosine since kind of would that work?
Did you mean like to go like this?
Yeah.
Good question. Can I do that?
So I thought they were like kind of circles of each other.
But aren't you taking care of the numerator first and then divide by the denominator? Remember, this is a couple. Right? They have to go together. So the top has to be simplified first before you can dip to the bottom.
Got it.
Okay? So if that was your iffy move, that would be a no. Do not do that. Next. What do you do? Uh-huh.
So would you kind of then multiply both parentheses by cosine and sine?
Multiply both sides by...
Cosine and sine for like a common denominator.
Oh, find the common denominator?
Yeah.
Okay, let's do that. Yep. So let's try that. So the first fraction, I would have 1 minus that. So you multiply the by cosine, right? And cosine for that first one. And then divided by this one. You want to do a sine. Someone agree with this so far or no? Okay. Yeah, I wouldn't know any better. Okay. I would definitely try that. Then that means my new numerator is now sine squared and cosine. Yes or no? Like that? And again, I don't know any better. I'm just going to try it out. This one already has sine maintained, so that's going to stay as that. Then this one has cosine, so that's going to stay. Now this one now has cosine square of theta times sine of theta. Someone agree so far? Okay. The only thing I can do on your paper is verify your algebra. But besides that, we can try a lot of different ways. Now can I put it over one fraction? Okay, so this becomes a cosine divided by, this is now a sine. This has sine square of theta, cosine of theta minus sine of theta. This has cosine square of theta times sine of theta minus cosine of theta. Now what do you guys want to do?
You factor out the sign on that side and the cosine.
Okay, factor it out. So factored out a sine on this side. That means you have a sine and a cosine left. Take away 1. Is that true? Okay, all over cosine. Then can I multiply by its reciprocal and factor? Yep. Okay, so multiply by reciprocal. Over here, what are you going to factor? A cosine. Then you are left with what, Lauren?
Cosine times sine minus 1.
Cosine times sine minus 1.
Which is the same as that.
Are these two identical? Yes. So can I cross them out? Okay. Then you are left with sine square on the top. Yes or no? Sine square on the top divided by cosine square on the bottom, which means that is your tangent square, and that is your goal, isn't it? Yep. Okay. Good job. All right, try D for dog. How far can you go with D? So try it out. It doesn't matter if you can't finish. And the more you try, the faster and the better you'll get. So Dylan, which side did you use? Left side? Okay, so cosine of theta divided by 1 minus sine of theta. Okay, step 2, what did you do next after you've chosen? Julie, what do you go next? By the way, did you pick left side or right side?
I didn't get to that.
Okay, what side did you want to pick?
The left side.
Sure.
Then you multiply both top and bottom by 1 plus sine theta.
Is it because that's what you saw in the goal?
Yes.
Yes, that is definitely very good to do. Then step 2, what did you guys end up with if that's what you do?
Cosine times.
Did you want to distribute or no?
No.
No, okay, so cosine of theta times 1 plus sine of theta all over. What is all over?
I
minus combined bottom part, it would be 1 minus sine squared.
Okay, that works. And then what did you do after?
I converted, because it was an identity, I converted that to cosine squared.
Cosine squared theta. So now this is, I'm going to copy that down on the top. And what's your next move?
Cancel out.
Cancel. So what are you left with?
1 plus sine theta over cosine theta.
Very good. And that is your goal, right? Excellent. Try the next one. E for excellent. Haha. Sounds pretty good for breakfast. What side might you want to pick on this one? The left side?
I'm just kidding.
Okay, pick a side. Noelle, what side do you want us to start with?
On the right.
On the right side. Did you finish, Noelle?
Mm-hmm.
Okay, maybe you can help me write everything, okay? All right, what's step 2?
I changed cosecant to 1 over sine.
Okay, so 1 over sine minus sine. Oh, did you write division like sideways?
Sine over 1.
Sine
Then I
over-
wrote division sideways, yes.
Okay, so like that, like that. Okay, good. What's your next step?
Then I multiply the sine over 1 times sine, like sine.
So did you do common denominator?
Yeah.
Okay, so what Noelle did is she went like this, minus sine square over sine, like that. Okay. And then did you multiply by sine still, or divide by sine still, or
Yes, multiply that.
divide by sine? Okay. And step 4?
Then I combine the 2.
Okay, so combine those guys. Divide still?
Yes.
Okay. What's your next move?
Then I made it into cosine squared.
Cosine square of theta over sine of theta. And then divide still? What's your next move?
Then I multiplied by 1 over sine.
Okay, so multiply by its reciprocal. Okay, and then?
Then I combine sine.
Okay, so the cosine square over sine square, which will lead you to? Yay, good job, Noelle. Excellent, nicely done. Any questions for Noelle there? Pretty sure you got that one. What? You guys are awesome. All right. F. There you go. This is the last one. Yeah, so far so good. Yes. Can't skip steps, okay? I know you gotta do basic math in your head. Can't skip steps. This is the last one. If you're done with anything, or this one, you can grab a book and start your homework. What side? The right side? Left side? Okay. Daniel, are you done?
Yes.
You want to help us out?
Yes.
Okay, so you picked left side?
Yeah.
Okay. And then what did you do after?
I put the this OC theta and sine to theta like parentheses.
Like this?
Yeah.
Times, and then this maintains like that?
Yeah.
Okay. Now what?
I just canceled out.
Okay, so cancel one of it. So 1 minus sine square. And then,
That turns into cosine squared.
yeah. Awesome. DI. Perfect. That is done.